Welcome to today's webinar. This is Octopus Deploy and Clear Measure Q&A, and we're going to go into some really great topics. We're so pleased you're here. My name is Jeffrey Palermo. I'm the Chief Architect and CEO of Clear Measure. We're a DevOps-Centered Software Engineering company and US-based Octopus Deploy consulting partner. Over to you, Paul.
Hi everybody, I'm Paul. I'm the founder and CEO of Octopus Deploy.
All right, let's get right into it. We have a lot of information to cover and not a whole lot of time. We want to be respectful of your time here. We have a throng of people on this webinar, and so as we go through, go ahead and make sure that you use the Q&A window to pose any questions on the webinar topic itself. But for questions that you'd like us to answer about automated database deployments, make sure to go to octopus.com/Slack and join the Slack channel and go to the Pound Webinar channel. And you can not only have a conversation there as we go along, but also also after the webinar is over, that's an avenue where you can continue to ask questions, and that channel will keep going for the community. All right. So our agenda right now is what makes the database different, state-based and migration scripts. We're going to cover topics there: rollbacks, zero downtime, and then also putting it together. So one of the things that we see in our practice with automated deployments is that once the build and deploy pipeline is automated, we want to add in quality control steps, and so we'll talk about some of those as we move along. And when something breaks, we want to stop the line. So we have lots of questions, and we'll go through a Q&A format as we go through here. But our mindset is an automated DevOps pipeline, the 3 ways of DevOps: flow, feedback, and continuous learning, with a special focus on the database. So why don't we just jump right in, Paul?
Sounds good. So our VP of product posted this on Twitter the other day, and I thought it was a good introduction. So he observed that a lot of articles on deployment patterns will talk about how to do zero downtime deployments and canary deployments, blue-green, etc. But they don't tend to include the database. And there's something common about that. There's something that's different about the database. Well, what do you think that is, Jeffrey?
Sure, and it really is different. The database is completely different. I think it's exactly right that tweet that in the real world there's no applications without a database, and of course we see in the quick starts in the articles. But compute components like web applications or offline jobs, they really don't have any state. They can be, from a deployment perspective, they can be destroyed and put back really easily. And that's probably why all the simple and trivial DevOps pipeline examples that you find on YouTube and elsewhere have a website but no database, because that is the easy part. Now also, storage components, whether it is a relational database or a JSON collection or even a directory of files, storage components in your applications have to preserve data for years. And any type of storage, and we'll talk about relational databases here, your deployment has to cope with data that's probably been there since before the word DevOps was coined. And if you have data from, say, before 2010, that's definitely true. And so when it comes to software, the data is more likely to be the company asset rather than the code that operates on the data. And some of that data probably existed many years ago in a file cabinet of some sort before the company went through digitization and actually created that computer system. And so at some point, the current applications into the future, if you fast forward some number of years into the future, the current applications that you have will be replaced by different ones, but the data is going to live on and it'll continue to grow and change. And so when it comes to database DevOps and automated deployments, the test environments are going to be easier to manage because you can drop and recreate those databases. You don't do that as frequently in UAT when you need complex data test sets to be long-lived, and you definitely don't do that in production. So you need to find out how to modify the database schema while keeping it operational. So there's the few factors that are the same when we deploy, and then some that are different when designing the right deployment process to manage a database. And so let's look at them real quick on the next slide. And so what we have here on the screen is a diagram of how we package up the database and then what kind of process we go through to deploy. So we have we'll call it a version unit. The software system often has the schema structure, and then it has schema data. And we'll talk about the differences there. The schema, which is tables and everything, the structure of the database, that's owned by the software system, and that should be exactly the same in every environment. Some of the data is architecturally part of your schema, and it should be the same across environments. For example, if you have some standard lists that populate drop-down boxes, such as common name prefixes like Mr. and Mrs., these are going to be the same in every environment, and it's no different in production. And if it ever does change, it's going to be promoted across environments. Also, some data is configuration. You can see the box under the pre-production and production. There's a box for configuration data. So that belongs to the environment itself. And just like some configuration is stored in XML files or JSON files and it's poked in during deployment, some of this configuration is stored as records in a database potentially. And some systems have settings that could easily be stored in a configuration file, but they reside in a database table from time to time. And in this case, that table is environment-specific configuration. It would be different from environment to environment. Some other data is administrative data, without which the software doesn't do much. An example of this is user, customer, or account records. If you have no records of these types, then no user would be able to log in and use any of the software features. For instance, if there's not even an administrator level user account when you do a deployment, then nobody could even go in and provision additional users. So there's always some level of administrative records and data that has to be in a particular environment. And then the rest of the data is what you think of as normal data, constantly growing, constantly changing as people use the system. That's called user data. And so you can't just drop and recreate it. You have to preserve that data. And if we go to the next slide, well, actually, I should have gone to that slide earlier, but that's why the database is different, because you have to preserve it and you have to figure out how to morph it. And these different types of data have different needs in the environment. So now that we've covered that, Paul, what's the normal status quo at clients before they have automated their database deployments?
Yeah, I would say it's more common than not for customers that we work with to have not automated their database yet, but to be thinking about it. But there's a lot of things that prevent them from going ahead. And if you go to the next slide, I'll show what everyone will have seen this, right? So it's time to deploy a release. You've been working on some changes to your application that involves some changes to your database schema, and you take this SQL file. You may have lovingly handcrafted this by writing the T-SQL yourself, or you may have exported it from another tool. But this is the script that you want to run when someone deploys this to production. Sorry, my audio cut out there. So you take this script and you email it to your...
Yeah, I think we're having some audio problems with Paul. While he gets that situated there, I'll continue on because this is a great question that's been submitted from clients. sometimes the process is that you take a script and you email it around, and maybe your DBA has a hand in making sure it's the right change to make to the database, and then the different updates that are gathered together, and those are run manually in painstaking order, making sure that everyone succeeds in order. And then invariably something sideways happens midway through, and there's manual compensation. So that's what is normal at clients before they've automated their database deployments. It's a whole lot of just focus, and long deployments. And a lot of stress. Sometimes deployments happen, and it takes hours depending on what kind of compensating factors. Now, the gist is that we all want deployments to go smooth, and so we try to create this manual process where we're going to execute them in order, but it never goes exactly like we want it to. And then it's the manual compensation and trying to hotfix and debug on the fly that creates so much stress and has database deployments stretching out way longer than they should and causing a lot of organizational stress. Paul, do we have you back? All right. If some of the attendees might help out and just put into the Zoom chat if you're hearing the audio coming through, help us out. Make sure that. All right, appreciate it. So while Paul works on his audio, let's go on to the next. Let's go on to the next question here. So another question that was submitted and is a commonly asked by lots of folks is, what does an automated unattended database deployment look like? And this is a great question. With an application component like a website, we have some files that need to be copied and some configuration that needs to be poked into the XML or JSON files, and it's a complete overwrite in many cases. We can just delete the files and recreate. Not so with the database. And so let's back up and look at the architecture of a proven database deployment process. Let's take a look at what that looks like. So here we have a Git repository and then a continuous integration build. And there's some components that need to be present in your version control repository in order to facilitate that type of deployment for a release candidate that is packaged from a continuous integration build. Because when you're putting together an automated DevOps pipeline, that use that visual metaphor, that pipeline where you have water flowing through, and that water is changes to the software system. And just like water might not be completely pure, we don't want those impurities or the problems in the water to end up at the faucet and drink. We want the water to be as clean as possible. Same thing with software. We want the software to be as pure and free of defects, free of impurities as possible. So we have the pipeline. We want the water, the features, the changes to move through quickly and not have delay, but we also want to insert lots and lots of filters along the way so that we remove those impurities and we catch them. And so we're setting up that type of process, and it starts with the Git repository, which automates change control, and then we move to a build process, which, if you think of test-driven development, arrange, act, assert, it's going to do some things and then check some things, and then it's going to package up and produce a set of release candidates for that build, for that version, and then it's going to pass that down to the deployment process in Octopus Deploy in order to deploy. So in our Git repository, we have our application code, but we also, in the same Git repository, we need to have our database migration scripts, and we need to have a migration tool. On the open source side, the most popular one is DBUp. On the commercial side, the most popular one is Redgate SQL Change Automation, and that's our migration tool, and it runs and operates off of our directory of SQL scripts in order. And then we also from time to time will have a build time data set that we can poke in. It's not very large, but it's just enough so that the main happy path features of the application can be exercised. So our continuous integration build is going to clone the Git repository. We're going to provision whatever our build environment needs to be. If it's a Microsoft Azure environment, then we're going to provision a SQL database, and then we are going to execute our migration tool, which is going to use the scripts that come in that in the head of the Git repository, and we're going to compile, of course, whatever application code it is. We're going to do some unit tests and integration testing. We're going to use whatever data set is available and is checked in to go with those integration tests. We're going to use whatever static analysis is appropriate for the build. We're going to make sure that everything is stamped with a version number. And then if all that succeeds, we're going to create a release candidate package or set of packages. And in the simplest case, if we have a web application and a SQL database, we're going to have one NuGet package for the web application, and we're going to have one NuGet package for the database release candidate that has all the migration scripts in it. So with that there, that's what a pipeline looks like. Now we have a special offer, and this is, by the way, this is just one portion of an architectural poster for the structure of a automated DevOps pipeline using Azure DevOps Services and Octopus Deploy, and the two integrated together, and what steps go on. If we kind of zoom into the bottom right, we can see that we have 3 different types of environments. You'll never have fewer than 3 because there's 3 individual types. You need one of each type. Everyone knows production. Everyone also knows the manual test environment. You can call it UAT, staging, QA, whatever you want to call it. Even dev is a manual test environment, and you need at least one of those. You can have many if you want. And then we need a TDD environment. This is a no humans allowed environment. This environment is just for automation. Automated tests, we're going to automatically provision it. We're going to run automated full system acceptance tests, whatever tests require a fully deployed instance of the application, soup to nuts. And then we're going to destroy the environment. And when the next build comes along, we're going to do it again. So it's an automation only environment. And that's the third type, automation only, then manual verification, and then production environment. You can have as many as you need of each type, but you can have to have at least one of each. So you'll have, with any pipeline, you need a minimum of these 3 environments. And we see how Azure Pipelines orchestrates everything, but then delegates to Octopus Deploy to do the deployment, and then control comes back to Azure Pipelines for the execution of automated test suites. Our offer on this is, if anybody would like a copy of the full poster, Paul is going to be putting the URL in the Slack channel so that you can download. It's a 2-foot by 3-foot high resolution PDF. You can print it off at your local print shop on large poster paper if you like, and share it around. So that's available. Just check out the Octopus Deploy Slack channel, octopus.com/Slack, and that's how it's structured. But essentially, it's important to package up the release candidate properly. And then once you have that package, you can take the package, Octopus Deploy grabs it from the NuGet server, and then you're going to, in the TDD environment, you're going to drop and recreate the database and load the data set that you've stored in version. In UAT, we're only going to run the new schema changes. We're not going to drop anything. And the same thing on production. And then for UAT, we also want an on-demand capability to reload a data set if appropriate. So that's kind of how we treat the database deployment differently across the various environments. I know there's a lot there. This is what the Octopus Deploy process looks like. It's pretty darn simple because we just grab the NuGet package, we explode it on disk, we migrate the database, which is kicking off our, in this case, it's invoking Redgate SQL change automation, but it could just as easily run a post-deploy.ps1 file and execute dbup or any other tool, and then and we want to instantiate, in a lot of cases, instantiate a test suite so that it's ready to run. But that's kind of what that looks like. All right, and Paul, I think we have your audio thing sorted now.
I'm back following a reboot.
Fantastic. Well, perfect timing actually, because you kind of explain this slide really well.
Yeah, so So when it comes to dealing with these schema changes and data changes, there's a few rules that we follow and that we recommend following, and they create a process that that works really well in our experience. So the first rule is that any change you're making to either the schema or the schema data that Jeffrey's been talking about should be source controlled. Should be scripted. That's source controls rule 2. So the changes should be scripted. You can handwrite those scripts. You can use tools. There are a variety of DSLs for writing these scripts. Most people tend to just write them in T-SQL. When you're in Management Studio and you're changing columns or adding a table, every dialog in Management Studio has a way to create a script. So you take that script and then the next step is you put it in source control. So there should really be no reason why when someone is joining your team or wondering how the database has changed over time, that there shouldn't be a source control system where they can look and see all of the changes that have been made over time to the database. The next thing is to take those scripts when they're in source control, but number them sequentially. And the reason for numbering them sequentially is that then we know what order they need to run in. So you can see on the right, this is a set of scripts from one of our internal applications. Each one is just named with a script and then a number padded out just to make them sort alphabetically. And so when it's time to run these scripts, we know we just have to execute them in order. The next thing is to make them immutable. So one of the things we're going to be doing is as we run these, we're going to remember which ones we've run before so we don't have to run them again. And different tools will have different ways of remembering that. DBUp, that Jeffrey's mentioned a few times, uses a table. So it just inserts rows into a table to know which scripts it's run. Other tools will do things like hashing the script, etc. I think Redgate tend to use a function or something that returns the version that was last run. So we need to remember that the system is going to be remembering which ones of these have run before, and then it's not going to run them again. So it's very important that as soon as you've pushed one of those changes to a script, to source control, you can't change it again, because if you change it, someone may have run it and they won't get the thing that you changed. Now, if you're changing something that's like there was a typo in the script or something and no one has successfully run it, then of course you can fix it. Maybe if you're improving the performance of the script, that's okay. But generally try not to change them once they're in. Now, these scripts, if you think of like a team on like a 2-week sprint or a month-long sprint working on some features, what tends to happen is you'll make a bunch of changes to the model and you'll change your own data. You'll add stuff to a class in C# code. You'll add some columns, and then sort of like just before deployment time, you start to think, oh, that doesn't really match what the database looks like in production. I'd better write this migration script. When you do that, you tend to forget the things you've changed and the intent behind some of those changes. So we recommend, as you're starting to think about changing the database, write those scripts up front, because it'll force you to think through how the data, like the motion of the data from the schema that it's currently into the new schema. Think about that now, because it's going to affect also how you change the application design, and it's going to make it much more likely to succeed. And then the final rule is the same set of migration scripts running in every single environment. So if you've got an application where you've got multiple production databases, or you've got, let's say, an application that you deliver to end customers, and each of those end customers are running some version of your application, it should be the exact same set of scripts. The reason why this matters is you don't deploy to production as frequently as you deploy, hopefully, to most of your other environments. So during a sprint, you may do a bunch of test deployments, a whole heap of dev environment deployments, and then you do one deployment to production. And it's important that production deployment succeeds. And the way to increase the chances that it will succeed is to have it so it's running the exact same set of scripts that you've already run 15 times before through all your other environments. This set of scripts works really well too if you've got a new developer joining your team, and every developer has their own local SQL database. They just run the scripts sequentially. And if the migration tool can run from your development environment on developer workstations, that's a great way of spinning up new databases. If you're making a change, you then just add another script. The developers get latest from source control. They run this project, and they've got the latest schema as well, and the database is staying up to date. Developers obviously put lots of different test data into their databases. So when one of these scripts run, you're also getting the benefit of running it across all those developer databases. You can pick up any bugs before the schema change goes to production. But those are the six rules to successfully writing migration scripts.
Awesome. All right. So I think this question is for you, and we've gotten so many instances of this question. And actually, somebody, I think Will, also asked, "What's your perspective on database projects?" Which I think use DACPACs. The same question. So we have another instance. What about these? The DACPAC and the Visual Studio Database Project and SQL source control, and even entity framework migrations that use compare-based or state-based methods, and how do they differ from ordered migration scripts?
Yeah, so the way these projects work is you'll have a project that, instead of being that list of migration scripts that we just showed, so in the migration script example, you'd have something like script 1 creates a table, script 2 adds a column, script 3 adds another column, script 4 adds an index, script 5 drops one column, creates 2 new columns, script 7 adds a constraint, and the way you get to the end table is to run all 7 of those scripts, and that's how you get to the current version of the schema. These other types of projects, the way they work is you'll define the ideal database model as it is right now. So you'll say, I've got a table and it's got all these columns and it's got these indexes and these constraints, and you'll just change that file to change how the table is defined. And then what they'll do is they'll compare the database that you're looking at, which might be a dev database or a test database or a production database, and they'll work out how that compares to the model and what's different. So if you've ever run Redgate SQL compare, you can take 2 databases, look at them side by side, see what schema changes exist, see essentially what data changes exist, and it'll generate a bunch of scripts that get run. Now those projects, they can work well at dev time. They do miss some of the subtle nuances of changes that you might make. So the classic example is you've got a full name column. You're changing it to first name, last name, because marketing have said they need first name separately so they can email people by their first name. So you can't just drop the full name column and then create 2 new columns with null default values, right? Because you've just lost all your customers' names. So you need to add these 2 new columns, populate them with the full name value, and then drop the full name column. So these compare-based tools can miss some of those things because they'll say, well, there's 2 columns, there's 1 column missing, and 2 columns generate the drop, generate the add column statement. So there is a bit of a trap that you can fall into with those, but they can be good ways to generate that script. To me, the important rule, no matter which of these tools you use, is that those things are fine in dev environments. They're a fine way to generate that change script of what you want to run in production, but you shouldn't be doing that at production deployment time. So you should be comparing the model against your dev database or your test database, whatever the old schema was, or a backup of the production database, generating that script, testing it, making sure it works, putting in a source control, and then making that script the thing that you run when it's time to go to production. That way you have some sense that it's actually going to work and it's repeatable and it's reliable.
Yeah, I would add just a little bit of commentary over probably the last 15-ish years. The industry's first go at trying to automatically change a database in downstream environments was to put these comparison engines in place and try to detect what was different and attempt to generate some script that would on the fly generate the right thing and then execute it. And as we've gone along, we've seen so many situations where that just does not work, and there's so many situations where it'll fail and then you don't have a reliable deployment. And so what many in the industry probably at the same time have come up with is a more modern and just really foolproof approach, rock solid approach, and that is strictly sequenced SQL files, where engineers really look at the changes one at a time, and that way when it's deployed in a downstream environment, it's guaranteed to work because it's done exactly the same thing in multiple environments before it gets to production, whereas the generation approach kind of on the fly looks at production and then thing, the computer, we have to trust the computer and it fails just too many times. So.
And Andrew's just raised an interesting question in the Slack channel that I think is worth addressing. So I think we'll both have some answers to this. So it's a people question. How do you convince the DBA that hands-off database administration is safe? For years, the DBA has been the one that pastes these scripts into Management Studio, works through them line by line, reads the changes. Production deployments can't happen without them. And now we're saying developers are going to just commit these scripts to source control and just run them in production. How do you get the DBAs excited and involved in this process, and why aren't they excited?
Yeah, that's a good question, and it goes to process. One of the our webinar isn't about this. I just released my latest book called .NET DevOps for Azure, and if anyone's interested in chapter 4, tracking work, kind of goes to this. Whereas any stakeholder that needs to be a part of a software change needs to be integrated into the work process, and likely would need to have their own column on the Kanban board, because if a change is going to be made to a database and there is an organization or a team or a person that kind of owns or needs to be an approver of any of those changes, then that person or that team needs to have a column on the Kanban board so that it's a very formal process where, hey, that change is going to be proposed. Okay, they look at the change, they give the input, maybe it's altered or maybe they approve it, but either way, the columns on the Kanban board is the glue so that you can get all the people who need to be part of the process integrated, and so that you can actually chain together the workstations in this digital assembly line that you have, that is, on one end, ideas for what to change about the software, and on the other end, it's those changes manifested in a production environment with people actually using it. But everything in between is a series of columns, and you need to have people or teams that own a particular column and sequence them in the right order, so that everybody that needs to be included is included.
Yeah, I agree. And with all this stuff, we're not trying to remove the DBAs from this process at all. I think what we're trying to do is to decouple where they're involved. So we want to say the DBA is absolutely involved in reviewing the scripts that go out and having some kind of sign off or some chance to get things changed before they get run in production. But they shouldn't be the one actually running it. Like when you click that green deploy button and it's time to deploy the release to production, the DBA shouldn't need to be involved in that process, because the ideal workflow to me would be exactly as you've described. You start to craft this change to the schema. You generate the change script or something. You do it you commit the change to a branch in source control. You create a pull request. You send that to the DBA. They look at it. They consider the impact of the change. They add some comments, a bit of back and forth. It's it's over in their column now on the Kanban board. And then when it's reviewed, it gets merged into master and it's ready to go in the next production deployment. But they don't need to be the ones pasting it into Management Studio on the day of the production deployment and running it for you.
And we had, I think we have some questions on rollbacks, which we will get to in just a minute, but there was one question about, specifically with Redgate, not recommending DLM automation as a part of this guidance. Redgate last year, I think it was June 2018, renamed DLM automation to SQL change automation. And SQL change automation does use this more modern sequenced migration script approach. So on the open source side, DBUp is really the most popular. If you look at the NuGet stats, is the most popular free and open source tool that uses the modern migration approach to database deployments. And on the commercial side, Redgate SQL change automation is the tool that uses the modern approach. It seems like the whole industry slowly is moving from the compare and generate on the fly approach to a pre-designed and sequenced approach.
Great. So let's jump into the rollback question. When deployments fail, how do we deal with rollbacks?
Yep, absolutely. Man, this is such a hot topic, because when it happens, stress is high, and everybody here on this webinar knows that. You never want to be in a situation where you're asking yourself, oh, shoot, maybe this deployment isn't going to happen. Do we need to roll back? So there's the main point. A rollback is a failure. And unfortunately, nothing in continuous delivery is really designed to go backwards. And so when you have an automated deployment process that just unexpectedly failed, let's think about this. Are we really going to trust that same automated process that just failed to then reliably perform an automated rollback? And most of us wouldn't. So we need to make our deployments a series of very small changes that have each been thoroughly tested. And that way we're never making big changes that fail and put us in a big rollback scenario, but just many very small changes in sequence. And so let's discuss some common scenarios where we can reduce the rollback problem and turn a possible rollback scenario into a roll forward scenario. So let's take the example of splitting a phone number field on a database. Once that data is destroyed, if we're taking a phone number field, splitting out the area code and splitting out the rest of it into 2 new fields, and then getting rid of the original phone number field, once that original phone number field is gone and that data is destroyed, the only rollback that you can do is restoring from a backup, because there's no automated process in the world that can undo what just happened. And also, there's no compare-based way in the world that could even figure out how to do that. So in order to change a possible rollback scenario into a roll forward process, we create compatibility shims in the shared state that's compatible in the database, that's compatible with multiple versions. And then you can redeploy the old version of the application if there's a failure. And so in effect, a lot of people are agreeing on the same guidance, and we certainly agree with the premise of splitting out destructive changes until the application has proven to no longer need them. So adding additional columns and adding new objects to the database, and then go a release or two, and then come back and remove the now dormant and dead parts, dead objects in the database schema. So step 1, you modify the database with the new and old schema compatibility. You add those 2 new columns. Step 2, you deploy those database changes. And now your application version A is on database version B. Then you modify the application, you deploy, so now application B is on database B. And now we modify the database to remove the old schema elements and then redeploy. So it's important to have, like we talked about before, all 3 types of environments in your DevOps pipeline so that your deployment is well practiced before the production deployment. Deployment failures should be a very rare occasion, and when they do happen, you want to thoroughly post-mortem them. Even in pre-production environments, it's very expensive to design a continuous delivery value stream that allows going backwards at any time on a whim, and we rarely see that compatibility even start to provide a return on investment. So like Paul mentioned before, there are some tools that are designed to inspect that target database and decide on the fly the right thing to do. But because you're in the middle of a failure scenario, right then and there, you're in uncharted territory. So don't rely on a quote down migration or an undo migration or compare to automate this for you. It's just not going to work. You want to design your deployment pipeline to fail in a pre-production environment so that the exact set of scripts being run in production have been run several times on environments beforehand. So in short, automated rollback is not something that you're going to find in a DevOps environment. Instead, you design it so that it really does fail before it gets to production, and you severely minimize the times you get in that type of situation.
Yeah, to me, rollback has a huge time component to it. If you in our experience, when you follow these kind of processes, production deployments don't actually tend to fail that often. What tends to happen is you successfully deploy a really bad change to production. So you've deployed something and it's a little bit broken, but maybe the application is still live. And an hour or two later, you realize, we need to roll that back. We need to undo some of those changes. At that point, most people would say, well, take a backup of the database and restore it. But you've collected a few hours worth of data during this process that you may not want to lose either. So any kind of rollback if the rollback is like 1 second after the deployment's happened or through the deployment, then sure, restore to backup. Getting beyond that, it becomes a real judgment call as to how valuable that information is, how long it's going to take to resolve and fix the problem and roll forward, like you said. That's why DB up is DB up, not DB up and down. Roll forward.
Yeah. One of the questions related to this general topic is asking, what do you do when you have 5 developers changing the same store procedure multiple times each? And so that's a good question. That is actually the same issue if you have contention on any other code file. If you're in an application and say it's in .NET and you have a C# class and you have multiple developers trying to change that same class, yeah, they're going to step on each other. And the same problem would happen if they're trying to change the same columns of the same table, same store procedure, same user-defined function. So you're going to have, because we are translating the structure of the database into code, source code that's stored in the Git repository, then all of the same team dynamics apply as with any other type of code. You need to work well as a team so that you avoid contentions, and you want to have a well thought out branching strategy and pull request, because yeah, if you have multiple people trying to change the same thing, you're going to have contention regardless of what part of the application they might happen to be changing, not just the database.
Yeah, that's an argument in favor for source control, right? Because if you've got these people working on the same store procedure, in SQL Server it will just overwrite for each person. So at least merge conflicts aren't fun, but they're certainly more fun than having your changes completely overwritten.
Yeah, good point. Good point. It raises the issue to the surface so it can be dealt with at the team level. All right. So here's this is another great question that the attendees have submitted. How do I configure a 0 downtime deployment when the database and application components both need to change at the same time?
Yeah, so this is a problem, isn't it? Because the example would be you've got an application that is expecting a new table to be there, and you've got let's say actually you've got an application that's expecting a new column to exist on a particular table. So you've got this application code change to go out, and you've got the schema change that adds this column. And so which one do you deploy first? If you deploy the application and someone tries to use that feature, it's not going to work because the column isn't there. If you deploy the schema change first, you might have code that's reading that and not able to understand what this column's there and raises it as an error. So there's a lot of there's some things that you can do to work around this. Things like adding columns, etc. In your code, your ORM can hopefully support the ability to ignore extra columns that it wasn't expecting. So that takes out a whole class of problems, like anytime you're adding a column or something like that, that will be fine. Obviously, if you're adding a new table, you haven't deployed the code that uses that table yet, that would probably be fine too. When it becomes things like you're deleting stuff, deleting a column or renaming, that's where the old code is going to break and struggle. The only way to handle changes like this is to phase them. So what you would do is deploy a new version of the schema that has both the old and the new column, deploy the application that can deal with that column, and at the same time, the old application will continue to work. Once that deployment is done, you then do another deployment, because now the app is running the version that understands that column is missing. You deploy a new version of the application or a new version of the data schema that then removes it. So instead of a change script that says, create these 2 new columns, add some data to it, and drop the old column, you do a script that creates the new columns, populates them, let that run in production, do your production deployment, get the application all up to date, and then once you're sure that old column's not being used, do another deployment that removes the old column. And this allows the application to continue running with no downtime. You typically have to support, like the application code has to support both the database schema has to support both the old and the new app, so version N and N-1. It becomes a lot more messy when you've got multiple end customers for your database. So again, this example of what happens if you're a solution provider who's creating the schema, creating this application, then giving it to end customers to run. Because sometimes, like, we'll have customers upgrading from on their on-prem Octopus servers, where they might not have done an upgrade for like a year, and so they upgrade to the latest version, and we have to run all of these changes, over a whole year. There is no way to do that without some downtime, because some of those scripts will add things, some will remove it, and at some point the application will continue to work. But if you can come up with some kind of rule, like the schema will always be compatible with the current version of the app and the previous version of the app, or the previous 2 versions of the app, and that's going to allow you to do some kind of zero downtime deployment. Hopefully that makes sense.
Yeah, and one thing you can do to test it before you even get to production, if you just use Selenium or some other UI automation tool, just take one of the screens and just execute in a loop, processing a transaction over and over and over again. Then as you deploy to, say, an environment you keep up and running for that, as you deploy, you can make sure that tool that is constantly generating usage never fails. And that'll kind of prove that as you deploy, none of the transactions being dropped, because that would be a user's experience. If a user is using your system and then all of a sudden they're doing something and they get an error because maybe the node that they were on had a app pool that was recycled, or if you accidentally took the database offline instead of only doing online changes, things like that. So the theme is you design it, but you need to test that it actually works like you intended it to.
So what does all this look like in practice?
Let's see, did we? Oh, yep, we skipped a slide. Sorry about that.
Yeah, so what does all this look like? You've got a demo, I think?
Yep. So the I have some diagrams, and in a previous webinar we did an interactive demo, and it takes quite a bit of time, but we'll put a link for a recording for what the actual user experience looks like. But let me walk you through the actual mapping of an application and the different packaging. And we can see that we have a SQL Server database schema, and we're packaging it up in a NuGet package, but also the other components of the application are packaged up as well. And then we have acceptance tests. And I think we already covered, we already showed this slide previously. So we'll just blaze through here. And I think that we are missing a slide. Well, that's unfortunate, Paul. Somehow we dropped one of these. Well, that's that. Okay, so tell you what, I'm gonna make a video available to all of the attendees here, because we had a demo that is not working out here, but essentially it was a demonstration of how to add a SQL script to a application and then flow it through. We'll make that recording available to all of the attendees, and then go from there. We do have a free offer for every attendee of this webinar, and that's a free 30-point inspection of your Octopus deploy environment. And if you have, even if it's a small application, large application, that's a free offer just for attending this. and we'll be happy to offer that to anybody, any of your teams who attended this webinar. Paul, any parting thoughts?
Databases are hard, but they're an unfortunate reality of our DevOps world, aren't they? So hopefully this has been useful to everyone. Thanks for attending the webinar. We'll send an email to everyone who attended with those recordings. And thanks very much, Jeffrey.
Awesome. And by the way, if you put the questions in the Slack channel, they will be answered. And so make sure to go there. All right. Everyone have a great day, and cheers.
Thank you.